Okay, welcome to the conclusion of this Jupiter moon hopping video series that I'm doing. I'm certain that this will be the last video because we are here at Io, so we're at the last moon in the sequence, and we're getting ready to land. We're only 2,700 meters away from the landing site, and we're all set up. We lowered one side of our orbit, although due to Jupiter's strong gravity, it's perturbed our orbit quite a bit. You know what I should have did? Let me actually switch camera views here. Instead of using orbit MFD for the PEA, what I should have done was use interplanetary MFD and just reference IO and then change the projection because I can't stand weird projections. And then relied on its PEA because it's far more accurate. So yeah, I should have did that when I did the deorbit maneuver. I didn't think about it. At any rate, we are not too far away from the landing site. So we're going to go ahead and warp time forward till we get over there, and then we're going to do our dead level best to land. And we will have completed this whole flight on one tank of gas. Of course, we're using the Delta glider, which has a ridiculous amount of gas. Fuel has capacity. Its engines are just really efficient.
Rotation.
All right, let's rotate so that we're belly down to the ground or heads up. And let's warp time forward to we're much closer to the base. And at about 1,000 kilometers out, I'm going to check to make sure all my radio frequencies are set where I need them to be. I think they are, because I'm pretty sure in this scenario that I already had everything set up how it needed to be with the comm nav, because that's one thing I don't like to do is to go through and mess with all the comm nav stuff. So I try to remember to set it up in the scenario ahead of time. And I can tell that it already is. These are all the same frequencies that are used at Brighton Beach, so that's fine. So we're going to bring up VOR, VTOL, and we're going to watch for when we get in range of the radio beacon, which should be right about now. A couple more seconds, there it is. And let's get oriented
Rotation.
back to retrograde. And then we'll bring up burn time calculator to see how long this burn needs to be, which it'll be about the same as it is on the moon. So we'll need to start the burn when we're about 80 kilometers out. Be pretty close to that number. Okay, so we don't need base sync anymore, so let's bring up BTC on this side and put in that amount of delta V. So we're saying how long is it going to take us to get rid of, let's actually just round it up to 1,800, and we need 78 kilometers to get rid of that velocity. It's about what I thought it would be, about 80. Warp time forward, get closer to that distance. And we'll throw the landing gear down while we're thinking about it.
Gear down.
Let me check one thing real quick. Let me look at surface MFD. Yeah, no dynamic pressure, no static pressure. So there is just a little bit of an atmosphere here. You can even see it. Yeah, at least you can see it when the sun's in the background. But I don't think Orbiter actually registers it as any kind of an atmosphere. All right, bring back up burn time calculator, and when we get to 80 kilometers from the base, we're gonna press the burn button to burn down all that velocity. Okay, let's get rotated. Now we can go over to surface. Getting ready to burn. And burning, I think I was a second late on that, or maybe not even a whole second, but just a little bit late on that. You can see our base target right there. And we're coming in pretty high, so I'm not going to worry about... Yeah, we're at 22 kilometers, so I'm not going to worry about pitching the vessel back a little bit in order to prevent myself from falling, because we actually need to fall. And when our distance is a little bit closer, we're going to switch navs. I think when it's 30, no, it must be 25 when this one comes online. Really? Oh, it was 15. I thought it was 25. So landing pad 1 is right there. Landing pad 2 is a bit off. Landing pad 3 is even farther off, so we'll go for landing pad 1. Coming up onto the end of the burn, I think. Wow, we really overshot. How is that even possible? Did I start? I didn't start that late. No way. How can we be missing the base? I don't understand. I know I started the burn on time. Anyway, we're going to put in a little bit more velocity so we can move back toward the base now.
Translation.
It's not too bad. I mean, we've got a long way to fall, so it's not that big of a deal. Putting in a little bit of additional translation so I can get more lined up. Probably need to move forward a little bit faster than this, though. Make sure hover door or retro doors are open. And they are. So now we're going toward the base. And we're falling, and that's what we need to have happen. So 2 kilometers out, 2.5 kilometers out. Retro engines aren't as powerful, aren't nearly as powerful as the main engines, so we'll need to back off that horizontal speed here. Falling pretty fast, so let's put in some hover to just compensate for some of that, just so we don't get into trouble. Okay, back off the hover. Okay, we're 1 kilometer out from the center of the landing pad.
Rotation. Translation.
Slow down a little bit more. Translating a bit to the left because that green arrow's off of it. Slow down a little more. Slow down a little more.
You are cleared to land.
Vertical speed's getting out of control. I did not mean to climb. That's so stupid. I was looking at the base alignment. Let me go level. So we're only 22 meters from the center of the pad. I hate when I accidentally climb. That's such a waste. Over top the pad, moving a little bit to the... Well, we're not facing north, so I don't really know. Okay, put in a bit of hover just to make sure that we don't get our vertical speed out of control. Reducing hover a bit because we do not want to take forever to get down. One thing about the standard Delta glider, it obviously doesn't have any kind of landing autopilot, so it makes life a little bit more difficult, but I think it's good to do it every now and then, you know, just as a challenge to yourself. Because if you're just constantly using autopilots for everything, then you're not really piloting the vessel. But it's also probably more realistic to always use autopilots. I can't imagine going forward, like, you know, on the moon landings, I remember hearing that all the pilots took over manual control in the last few minutes of the flight for landing on the moon, but I would imagine going forward we'll probably rely entirely on autopilots. Computing technology is just so much better now than it was once upon a time, so I don't even know if they would be allowed to take over manual control these days.
1,000.
Okay, a little more hover. Oops, I overdid the hover again, darn it. Okay, we have the level horizon autopilot on, so we're not going to worry about tipping back or rolling side to side. Putting in a little more hover, we've only got 700 meters to fall.
$500,
A little more hover.
$400, $300,
Take out some hover.
$200,
And we're almost down. Put in another
100.
touch of hover.
$50, $40,
Now I'm going to be able to control hover with just translation. Trying to also keep myself centered on the pad.
30,
Took out just a touch of hover there because that's getting
20.
the vertical speed's getting too close to 0. Now I'm putting that a little bit of hover back in. Now translating to bring the vertical speed down. Almost down, turn off the level horizon. Now we can pretty much just hover straight down because we're losing vertical speed. And hover engine's off. And we're down.
Rotation.
1.32 meters off from the center of the pad, so there in the last few dozen meters as I was dropping down, I was losing focus on the position. But still, you know, again, anytime you're within, I think it's 20 meters of the pad, then you're actually on the pad itself. Might even be 30, I forget. I think it's 20. So if you're within 5 or 10, you know, you're really well centered. But I always like to see, you know, 0 point something. It's just makes me feel better. Alrighty, so that is the end of the Jupiter hopping video series that I wanted to do. And again, the reason I wanted to do this video series was because, let me check one thing here. Check our total delta V that we've got left. We have 10.3 kilometers per second left, so we used about 20 kilometers. I think we started off with like 29, so I guess we used about 19 or about 18.7 kilometers per second, about 18,700 meters per second worth of delta V for all those hops. So anyway, as I was saying, the reason I wanted to do this video series was to kind of show a little bit more about IMFD, since I've been learning more about it myself thanks to those training videos that I did with Dimitri, and thanks to the offline training that he's done with me privately. So I think that if you watch this video series, and especially if you follow along with it, at least do one of the hops or do a couple of the hops, and then try to do the same thing, you know, going from Mars to, you know, Earth or something like that. Because again, the principle is the same when you go from Ganymede, or when you go from one of the moons of Jupiter to one of the other moons of Jupiter. It's the same thing that you would do if going from Earth to Mars or Mars to Earth or whatever. So try it out. Check the notes, you know, that I wrote, and watch along with the video. And I think by having those two sources of information to go on, that you should be able to have a lot of success with this. And if you find the notes useful, let me know. And if they're not useful, let me know. If the wording is bad, or if the steps are confusing, let me know, because I do want to work on it. You know, it's a document that I'm not necessarily going to put it on Orbit Hangar or anything, but just the people that watch my video, I think it'll be a good resource to help them learn how to use IMFD, because it's a very powerful MFD. It's like Transx, except it just has a few features about it that make it even nicer. There are some things it can't do that Transx can do, so we need both. But it's nice to be able to use IMFD also. And for the first couple of years, for the first like 3 years that I was using Orbiter, I was held hostage by Transx. It was all I knew how to use. And every time I looked at IMFD, my eyes just glazed over. And it's weird too, because I don't really think IMFD is any harder to learn. I guess it's just because I didn't know anything. So when I learned Transx first, it was just somehow easier because it was the first thing that I learned. So I don't know. Anyway, check for links again in the description. I've got a Facebook page. Check that out, a Facebook fan page. I post all my videos there. And I post other pictures and space-related content, stuff that I can't post on YouTube. So if you're interested, check that out. And look at my frequently asked questions. There's a link to that in the description below. It's all the way at the bottom. People always ask me, like, what kind of video recording software am I using? What joystick am I using? What are my computer specifications? And they also ask me various things about Orbiter, like what textures I'm using, what add-ons I'm using, what MFDs I'm using, things like that. All of that is answered in my FAQ. So if any of those questions and more, so if you have any questions, check that resource, and it'll probably answer a good number of your questions. And if there's something in there that's if you have a question that's not answered there, by all means put it in the comments area down below, and I'll answer that. And if it's a really good question, I'll even add it to my FAQ. So that's it, and I will see you in the next video series. Okay, welcome to the conclusion of this Jupiter moon hopping video series that I'm doing. I'm certain that this will be the last video because we are here at Io, so we're at the last moon in the sequence, and we're getting ready to land. We're only 2,700 meters away from the landing site, and we're all set up. We lowered one side of it. I'm going to check to make sure all my radio frequencies are set where I need them to be. I think they are, because I'm pretty sure in this scenario that I already had everything set up how it needed to be with the comm nav, because that's one thing I don't like to do is to go through and mess with all the comm nav stuff. So I try to remember to set it up in the scenario ahead of time, and I can tell that it already is. These are all the same frequencies that are used at Brighton, and then relied on its PEA because it's far more accurate. So yeah, I should have did that when I did the deorbit maneuver. I didn't think about it. At any rate, we are not too far away from the landing site. So we're going to go ahead and warp time forward till we get over there, and then we're going to do our dead level best to land. And we will have completed this whole flight on 1 tank of gas. Of course, we're using the Delta glider, which has a ridiculous amount of gas. Fuel has capacity. Its engines are just really efficient.
Rotation.
All right, let's rotate so that we're belly down to the ground or heads up. And let's warp time forward to we're much closer to the base and at about 1,000 kilometers out of our orbit, although due to Jupiter's strong gravity, it's perturbed our orbit quite a bit. You know what I should have did? Let me actually switch camera views here. Instead of using Orbit MFD for the PEA, what I should have done was use Interplanetary MFD and just reference IO, and then change the projection, because I can't stand weird projections.